Here I'm going to demonstrate method 1, which basically is breaking each of these two vectors into their perpendicular components. Let's call this vector A, which makes this one here, let's call this the y component of A, and let's call this the x component of A. To find the y component, given this angle, AY here is the adjacent side, I'm going to write down the cosine of 20 degrees is adjacent over the hypotenuse. Multiplying both sides by 300, we're going to get 300 times the cosine of 20 degrees, which is 281.9. We're going to do a shortcut here. You will notice that this is the product of those two. And in the same way, the opposite side is going to be 300 times the sine of the angle, which in this case is going to be 102.6. We'll call this over here vector B, which would make this, notice the arrows are important. This is B in the y direction, and this is B in the x direction. Using our same shortcut, B in the y direction is going to be the hypotenuse times the cosine of 10, which is going to be 59.1. B in the x direction is the opposite side, and for opposite, we're going to do 60 times the sine of 10 degrees. And that's going to be 59, oops, sorry about that, 10.4, my apologies. And what is a really good idea to do, and you can even do this in terms of terminology, beside this one, do that. Beside this one, do that. Because the first vector goes up and to the right. The second vector goes up and to the left. And that's really important that we draw these arrows. What we're going to wind up with is this and this. If I take the two upward components, which are both pointing upward, I am going to get 341. Again, that's by adding the 281.9 and the 59.1. This one here, we're going to get by taking this value, which is 102.6 to the right, and subtracting that value, because it's 10.4 to the left, and we're going to wind up with 92.2 to the right. This is our resultant. It is the sum of the two vectors. For the magnitude, well, Pythagorean theorem says this squared is 341 squared plus 92.2 squared. I'm going to add those up and take the square root. And I'm going to find out that this is 353.2 kilometers per hour. To get this angle in there, I'm going to do the tangent of the angle. Tangent is opposite over adjacent. So we have to do the inverse tan of that. And I'm going to get, when I do this, 15.1 degrees. Therefore, the resultant vector is 353.2 kilometers per hour, and we're going to call this north, 15.1 degrees east. Going back up to the very top here, if you wanted to, this is getting cluttered, but I could have done this and this and used 70 degrees instead. In the same way, I'm going to erase this. In the same way, I could have done this and used 80 degrees instead of 10. You could even, if you wanted to, have left it like this and called this angle 100 degrees, and it actually would have taken care of the fact that this one's going left in the first place. Anyway, there are a lot of different ways of doing this. Bottom line is, find this, Pythagorean theorem to find that, and then inverse tan to get the angle. That's how we're doing this question. A lot of steps, but very mechanical.